Chapter 4 Geometry. In the previous class, we have already studied about plane figures, creating shapes through paper folding, plane and curved surfaces, and 3D figures, which come across in our daily life. In this chapter, we shall learn more about them. We will also learn about perimeter of rectilinear figures. We will also discuss nets of some solids. Point. A point is a mark of position or location on a plane. It has no length, no breadth, and no height. That is, it is a zero-dimensional figure. It is represented by any capital letter of the English alphabet as P, read as point P. For example, the tip of a needle, pencil, etc. Line. A line is a straight path joining two or more points and extends indefinitely in any direction. It has no endpoints. It has no fixed length. It is a one-dimensional figure. The two arrows at the ends of the line show that the line can be extended. For example, a railway track, a road, etc. Line segment. A line segment is a part of a line. It has two endpoints and we can measure its length. It is also a one-dimensional figure. For example, edge of a book, paper, or chair. Ray. A ray is a part of a line that starts from one fixed initial point and indefinitely goes only in one direction. For example, sun rays, moon rays, a beam flashed by torch, etc. Plane. A plane is a flat surface that extends indefinitely in all directions. It is a two-dimensional concept. For example, surface of a tabletop, a sheet of paper, etc. Straight and curved lines. When a pencil is moved along objects with straight edges, such as a ruler, a geometry box, a book, a dice, etc., we get a straight line. When a pencil is moved along a curved edge of a coin or our hand, we get a curved line. Open and closed curves. Given below are some examples of curves. In the figures given above, curves A, C, and E do not end at their starting point. Such curves are called open curves. On the other hand, curves B, D, F, and G begin and end at the same point. Such curves are called closed curves. The curves B, F, and G, which do not cross themselves, are called simple closed curves. Polygons. A simple closed figure made of three or more line segments only is called a polygon. The line segments that form a polygon are called its sides. The point at which two adjacent sides of a polygon meet is called a vertex of the polygon. Triangle. A triangle is a simple closed figure made of three line segments. In the given figure, ABC is a triangle. It has three sides, namely AB, BC, and CA. Three vertices, namely A, B, and C. The symbol for triangle is triangle. Thus, triangle ABC means triangle ABC. While describing a triangle, we may name the vertices in any of the following orders: triangle ABC, triangle ACB, triangle BAC, triangle BCA, triangle CAB, and triangle CBA. Quadrilateral. A simple closed figure made of four line segments is called a quadrilateral. In the given figure, LMNO is a quadrilateral. It has four sides, namely LM, MN, NO, and OL. Four vertices, namely L, M, N, and O. Remember, number of sides, name of the polygon: 3. Triangle, 4. Quadrilateral, 5. Pentagon, 6. Hexagon, 8. Octagon.
A polygon should have a minimum of 3 sides.
Adjacent sides. The sides of the quadrilateral having a common vertex are called its adjacent sides. LM and MN, MN and NO form pairs of adjacent sides. Opposite sides. LM and NO, MN and LO are the two pairs of opposite sides. Diagonals. The line segments joining the opposite vertices of a quadrilateral are called its diagonals. LN and MO are the diagonals of quadrilateral LM and O. Special types of quadrilaterals. Rectangle. A rectangle is a special type of quadrilateral in which opposite sides are equal, diagonals are equal. In the adjoining figure, quadrilateral ABCD is a rectangle, as AB is equal to CD and BC is equal to DA. AC is equal to BD. There are many things around us which have the shape of a rectangle. Examples: each page of a notebook and a playing card have the shape of a rectangle. Square. A square is a special type of rectangle in which all the four sides are equal. The diagonals of a square are also equal. The adjoining figure shows a rectangle in which PQ is equal to QR is equal to RS is equal to SP. So, PQRS is a square and diagonals PR is equal to QS. Examples: a chessboard has squares on it. Many floor tiles have the shape of a square.